When we look at the universe on the grandest scale, it does not look like a random scattering of stars. It looks like a masterpiece. It reveals a structure of breathtaking elegance, a filigree web of light stretching around immense empty voids. It's beautiful, but as we explore in chapter 3 of our book, that beauty is a mask for extreme violence.
Welcome back to In This Universe We Are Alone. I'm Thomas and this is Nishelle. Today we are zooming out to a godlike perspective to look at our home address on the biggest scale, Laniakea. It is a Hawaiian word that means immeasurable heaven. But we must dispel the romantic notion of a peaceful cosmos. The universe is by default a hostile and lethal environment.
Laniakea is a supercluster, a gravitational watershed containing 100,000 galaxies. They are all flowing along these filaments towards a mysterious focal point known as the Great Attractor. To understand the probability of life, we have to look at where the vast majority of these stars and galaxies are located, the crowded cores of superclusters, and the bustling intersection of the cosmic web.
Life is resilient, but it is not immortal. It requires stability and time. But the dense regions of the universe are arenas of destruction. When you pack millions of stars into the close proximity, the gravitational perturbations constantly disrupt planetary orbits. Potential worlds are routinely ripped away, either flung out into the freezing dark of empty space or sent crashing into the searing hearts of stars.
And the threat isn't just gravitational. These crowded zones are bathed in high energy assault. Supernovae explode here at terrifying frequency.
And then there are the gamma ray bursts, very powerful explosions in the universe. They score their surroundings with unimaginable energy. If a single GRB goes off near a planet, it strips away its atmosphere in seconds. Any nascent biology, any delicate organic chemistry that has started to form is sterilized instantly.
It is a complete reset, and in the dense centers of superclusters, these resets happen far too often for billions of years of evolution to ever take place.
To survive, life needs isolation. It needs a boring neighborhood. It must retreat to the outskirts of these superclusters, to the low-density regions where the stars are not packed like sardines and where cosmic catastrophes are rare enough to allow the complex machinery of life to operate.
Which brings us to the first great filter in our calculation. We started at an incredible, generous baseline, what we defined using the Avogadro constant, 600 sextillion potential suns.
We must discard the crowded centers. We estimate that the vast majority of matter in the universe resides in these dangerous, high-density structures or unstable environments. Conservatively, we assume that only 10% of our initial inventory resides in the safer, low-density zones, suitable for the long-term stability that life requires. So we apply our first filter of 10 to the minus 1. Our number shrinks from 6 times 10 to the 23 down to 60 sextillion.
We have eliminated 90% of the universe as too dangerous, too crowded, or too volatile. We are left looking for a sanctuary within the remaining scattered light.
In a quiet corner of Laniakea, a stable spiral galaxy forms, our Milky Way. But even within this single galaxy, the traps are everywhere. In our next episode, we will look at the galactic habitable zone and why the vast majority of the Milky Way is just as deadly.
If you want to see the full math and scientific facts behind these filters, just pick up a free copy of our book, both in English and German. The links are in the description below.
Thank you for watching, and remember, the silence we observe is just the reality of our immense solitude. One must be so careful.
Laniakea.
Why do you laugh?
You didn't say environment, you said entities. Now I thought...
Astronomers find new superclusters all the time.
This does not change our message.
Again. I must repeat this sentence. Again.